So thank you for coming over. My name is Adi Rozenberg. I'm the CTO and co-founder of AlvaLinks, and I'm going to talk why do we need precise video delivery monitoring. Just like the session before that was very precise and monitoring was very precise, but it was done in a very controlled environment, like a LAN will be. When we go to the cloud, internet, or MPLS networks, we need to gain the same precision that we don't have today. So let's start with the presentation. So if we are here in this great West Hall, everybody talking IP. 95% of booth will show you that we are doing IP, cloud production, virtualization, AI, machine learning. Everything is going over AI, right? Over some kind of an IP network. We are doing sport production over IP. We are doing remote contribution with SRT, RIST, ZigZag, or NDI from remote facilities. We are bringing that to the cloud to do production in the cloud. We are restreaming that to secondary distribution and doing remote editing, everything done over IP. So the common thing that you might hear is that everything is over IP, so why don't we monitor and take control of that IP, that unknown thing that called an IP network? Video over IP is very, as we saw in the previous presentation, video over IP is very sensitive for network behavior. This is a known fact. Several protocols can overcome network problems. May that be SMPTE 2022-1, 2, 5. RIST, SRT, ZigZag have reliable protocols that work to recover lost packets, recover jitter, set up fixed reordering problems. We also hear the use of SMPTE 2022-7 to add seamless protection and switching. But how do we know which one to use for our application? Which one suits us best? Will that overcome the network problems that we might be challenged when we are come to do our hauling? Will the network support low latency? Will it support SMPTE ST2110? Is my cloud error-free? What caused the latest frame freeze? I don't know. We need to find out, right? And the basic problem that people here misled is that they don't look at the network as one of the main problems of their workflow. They are used to use old traditional method of monitoring, and they put their trust in the IT world to cover their behind. We are still in early staging of adaptation of IP. If you don't believe me, latest studies show that only 50% of users have gone full all IP. Any ST2110 new installation is over-celebrated to show, hey, we did that, it works. And why is that? Decisions have not been made on control and monitoring, whether that with NMOS or RIST. Users still blame the network for any failure. All tools are used for testing the network. And I'm talking about people using ping, traceroute, or just standard SNMP Armon monitoring to look at the network. But those tools look at the network maybe once a minute, once every 30 seconds. And you know what? Even if you do that once every second, with video, we need to have a tolerance of milliseconds, because 10 milliseconds of burst, 100 milliseconds of congestion will overflow or underflow our buffer. We need to know whether the resources are there to facilitate the delivery, but we don't have the right tools to do that. And I'm here to change that. So Let's start with what do we know about the network and how we need to address that. So just like seafarers in old times, the network is uncharted land, just like the sea. You go over the sea, you think you know the routes, you know the currents. Same with the network. You don't know, even that you think that you provisioned everything, you still don't know that. The network has an undetermined routing, whether that is in the cloud or open internet. The network creates jitter. The network experiences packet loss. The network can have packet reordering because it changes routing from time to time. And then some packets are reordered, and we have to take care of that. The network has undetermined latency. Who controls that vast uncharted land? Nobody knows. Is that Verizon? Is that AWS? Google? AT&T? It's made of segregated portions that combine together, and I'm trying to let people think about it as like a living being, because it's ever changing. What is there today will change the next day and in a month and later in the year. It is changing by the minute, right? And I can show you that. I will show you that it's changing by the minute. How do I take control over that? So one of the biggest problems that people, when they have a problem, they go to the vendor. They have a problem, they start with the vendor, whether that is the equipment manufacturer or maybe the telco provider. And with the vendors, they will come back with the basic sentence. Our responsibility ends at the NIC level. We tested that in the lab. We put it over simulators. You should do that the same. We don't know what happens when the packet leaves our domain, our NIC, and goes further. Same on the receiver end. We are responsible once from the point that the packet comes into us, then we take responsibility. We are not taking any control over what happens on the network, regardless if it's on the bench, on the internet, or in the cloud. So production engineers are focused on IPMX, AV, Pro AV, AV, KVM, and video quality. Equipment vendors are responsible for camera, encoder, decoders, ad insertion, multiplexing, whatever, AI, ML, and so on. Cloud service providers are renting virtual resources for you to use. Go try and ask an AWS what is going on with my network. They will say, we don't know, but your instance is running perfectly. That we can tell you. Network and telco provides you with a circuit. That circuit comes with an SLA and availability, but they don't understand video. They don't have the capability to understand video. It's not in their nature. Many IT folks don't understand high-quality video transmission requirements because when you do Cisco certification, nobody talks to you about video. They might tell you about voice over IP, but that is the extent of their knowledge. So one solution is to go for managed service providers, and they will build the network, and they will take some responsibility of the network, but that comes with a price. And it is okay to pay for that service because they take some charge and they take the control and they take the responsibility, and that's okay. So why do I think precision is key? Precision is important in the way that we measure the network and the ability to understand what is going on. It's a basic sampling theory. If I can measure it, I know that it is there. If I try to measure video once a second and I'm sending 20,000 packets, I only will have an indication on one packet out of 20,000. That is wrong. I can't measure latency, jitter on a 1 per second. It's not in the sampling theory that some of us learned at the university. So if I can't sample it, I can't see that. And I need to react. What do I need to react? As you said, the routing has changed. Do I need to react to that? If the routing has changed, what's changed? Is there an extra jitter because of the routing change? Is there extra packet loss because of the routing change? Does a hop suffer from congestion that may cause buffer overflow, jitter, packet drop, and so on? What may have caused that packet loss, jitter, RTT changes? We need to know that. We need to see that in real time so that we can react, we can make good decision making. Today, most solutions out there either don't know or rely on incident troubleshooting after the fact. What does that mean? Monitor by exception. Get an alarm, I have a freeze, okay, who caused the freeze? Let's pick up the phone, call this and that. And now let's try to envision what caused that. Let's put some kind of a monitoring equipment and hope that the problem will reoccur again so we can find it. But that doesn't work in 10, it's like 9 out of 10 incidents. So, of course, why does it matter to you guys? We need precision to evaluate network providers. We need to plan and monitor 70, 20, 22, that's 7. Even that needs monitoring. How do we choose cloud availability zone? Is it perfect for us? Is the latency okay? Is the jitter okay? Whether the availability is consistent over the long period of time. How do I set up my recovery buffer? If I'm using SRT, ZigZag, what do I need to dial in? How do I do root cause analysis? How do I analyze your equipment vendor? Is it good enough? Is it sending the data properly as I want it to do? How much time do I set for testing a new production site? How do I figure what caused the problem? Today, this is involved in heavy application of application of equipment and manpower and expertise to figure that out. You need to be an expert at my skill or even sometimes beyond to be able to do that in a reasonable time. Otherwise, you will spend days on top of weeks to figure out what is going on, and you don't want to be in that place. So if we had IT people in the audience, they would say, well, we are the ones to solve that, and I agree with that. IT people are the ones to resolve those problems, not the broadcast engineers. The broadcast engineers or anybody doing the streaming delivery is the customer. But the people that needs to perform their job is the IT people. But they are limited by the tools that they have. Most IT tools focused on data, on availability of network resources, and not focusing on video. You can basically see whether your switch is configured, whether there is a congestion alarm on a switch, how many users, what is the CPU load of an element, but that's it. Most predominant commercial tools in the industry sample the network. You know, let's do a poll. Give me a number. What do you think is the reasonable number that the IT tools measure the network? Anybody wants to guess? What is the sampling period of that IT tools will do to the network? Once a minute? Once a minute. So usually most will do between 5 minutes to 1 minute, but the best tool that I know that recently made a big splash about that, they will send one test packet at once a second. That's it. But most of the major IT organizations, they are trained to do network monitoring once a minute. That's it. Like even if you do a ping test, it's much more accurate than once a minute. But that is their job description. They are not at fault. They don't have the tools to do that. So just think about it. How many times did the IT team tell you that the bandwidth is there, everything is okay, but your video is freezing, stopping, and so on. If they do measurement once a minute, they cannot see packet or jitter burst, all those problems. And believe me, I've been to a situation where everything was excellent, a pipe of half a gig, but they had 25% packet loss, which was bursty 25% packet loss every few seconds. They couldn't measure that because that was not in their charter and capability to measure. So let's go forward. So what is needed? We need users and vendors need a single source of truth to guide them on the network behavior. The solution needs to be able to detect transient events like the cause of packet loss, route discovery, route changes, route switchovers, congestion events, indication on every hop, packet by packet basis measurement of latency, jitter, RTT, best loss, reordering. We need to be able to collect precise real-time and historical information for decision making. So after that, let's see some graphics, if you can see that. So in this example, we do real-time precise monitoring of a link and what we can discover. And this is testing the network every 10 milliseconds as an example. We can find error rate running at about 6% packet loss, ramping up and down. We can see routing changing because the hop has changed. You can see going up and down, meaning that the route is continuously changing. That will cause that error rate, that will cause jitter. You can see an impact of RTT going up and down based on the changes. You can see something that we are doing like ARQ buffer emulation based on the condition that we detect. We can see the rate going up and down. This is the difference between, this is the original source, this is the destination, that is caused by the packet loss, the delta is here. We can see the jitter, we can see events, we can see latency changes that are in response to the routing changes. That is something that cannot be detected by a standard IT tool. The only way to detect that maybe is using iPerf, but we cannot run iPerf continuously on our network. We need a tool that will run and do that with a precise measurement continuously and give us that information to allow us to do alarming. For example, this is an example of doing a pretest of a stadium network. This is a tier 1 organization testing a stadium. They came with a fly pack to the stadium, but the network was not there. So they test the network. You can see that in the red, and they are basically clamped, and there is a lot of packet loss showing. This is with the measurement tool. They didn't believe that it is, they said that it's a fault of the measurement tool. So in the middle, you can see them trying to stream and hitting the same problem. Then with the same measurement tool, we said, let's start and test the network gradually, step by step. Let's find where is the cap. So gradually we ramp up. We ramp up the bitrate slowly, step by step, until we hit here. There's a limitation here. We found it. It's like 8 megabits. And then we can go back to the service provider and say, hey, you are clamping us at 8 megabits. Fix your way. And immediately fix, and everything went perfect. Next, discovering of path. This is when we are streaming to the internet and the path is changing. So right now you can see here there were actually 3 different paths. In red, those are paths that were there, and suddenly they were gone, and the network was rerouted, and we discover a new route. Not only that we discover a new route, is that for the IT people, we also provide information on every hop, what is the RTT, so we can correlate congestion packet loss per hop to see that. So this is information which is tremendously important for the IT people to understand which hop or service provider is the one creating the problem, whether that is packet loss, congestion, jitter, and so on. Next, just to demonstrate the every minute type of routing changes, this is changing every minute. Every minute changing, causing every route causing different packet loss, different jitter, different latency, different RTT. So we need to figure out, based on this condition, what is the buffer that will be suitable to overcome that, or maybe to elect not to use this network or this provider. Maybe elect to go with a different service provider if we have that option. And if we don't, what will be the adequate buffer to overcome that? Because sometimes people go with the rule of thumb. I'm using SRT, I'm going to the rule of thumb, 120 or maybe 200 millisecond of buffer. But that 100 or 200 millisecond may not be good for the network condition that I have at this time, and I need to change my way. If I don't have that visibility and I go to the SRT statistics, I would not find that problem. All I would see is that buffer depleted, buffer overflow, error rate, and so on. With precise measurements, I can have that visibility and I can change my way. So how do we identify the root cause, and what tools can we provide to the IT folks to save that? If you remember, we had the route, we had the hops. So now we can measure and save and display every hop condition. So we can say jumps, spikes in their RTT that hints that there is a congestion that causes packet loss. We can change color changes, meaning that the route has changed, so it has a new color. And you can see here, based on the example before, different routes, different colors that signify that the route has changed, and every time it changes, it creates different problems. So now we gain knowledge. Now we can make decisions. We are not at the mercy of something is wrong, let's figure it out. Now that we have more information in our hands, we can make smart decisions how to go forward. Let's see another, maybe it's another example. In this example, we had a use case with, they tried to use path diversity. 4 different paths were supposed to be fully diverse. When I say diverse, I mean different origination points, different carriers, different data centers. Everything was fully, completely diverse. But apparently, no, they had a common choke point. And what we could find out, and I don't know if you can see the time, but 4 different diverse paths had almost exactly at the same time, exactly the same problem happening, meaning that there was no diversity. So spending hundreds of thousands of dollars of premium tier 1 telco circuits basically came to the same in-between obscure point. For sometimes they just match in and problems occur, and they are not diverse, and you cannot overcome those problems. It took this customer 2 months of bringing experts on top of consultants and vendors, and couldn't figure out what is going on. Installing precise measurement tools allow him to figure it out in less than 1 hour. It took 1 hour to find this shared resource somewhere in the network, and now he knows that he needs to change the diversity, go to different vendors so that this will not happen again. So to conclude, the IP network is here to stay and fuel our industry for the next decade, I hope. Unlike all traditional ASI, SDI, and satellite workflows, the network must be monitored constantly. The cloud is still an uncharted sea that needs to be conquered. Organization needs a reliable source of truth to show them what is going on. I don't want to say whom to blame, but to point the people, the right people, what is the problem and how to address and fixing that. Precise measurements are key to understand and controlling the network. Decision support, troubleshooting, training are key for successful operation. Question, anybody?